Section 9.6 is determining which method to use. The good news is this is exactly the same thing that we did in Section 8.5 when we were doing confidence intervals, only now we're applying it to tests of hypotheses. There's a variety of hypothesis tests and the task of selecting the appropriate test and procedure can be overwhelming. We've only got 3 population variables that we're testing claims about. If you're testing a claim about a population mean, mu, 2 things can happen. Either you know the population standard deviation or you don't. If you know the population standard deviation, you're going to do a z-test on your calculator. If you don't know the population standard deviation and you're testing a claim about a mean, what test do we use? T-test. If you're testing a claim about a population proportion, we use the 1-prop z-test. Notice on test of hypotheses, everything ends in test. If you look back at your notes from 8.4 or 8.5 when we did this for confidence intervals, you'll see everything looks exactly the same, except instead of test, I have interval or int because that was for confidence intervals. Also, the conditions that we have to check or assume to be satisfied are exactly the same as they were in Section 8.5. If you're testing a claim about a population mean, first of all, you have to have a simple random sample for everything in statistics, so I'm not going to write that one down. Either your sample size has to be large, or your population has to be approximately normally distributed. Only one of those is necessary. You can have both, but only one is needed. If you're testing a claim about a proportion, both n times p and n times q have to be greater than or equal to 10. If you're testing a claim about a variance or a standard deviation, you're going to use the formula chi-square equals n minus 1 times s squared divided by sigma squared, where the sigma is from your null hypothesis. And you look up your critical values on a chi-square table. The condition that must be satisfied here is that the population has to come from a normal distribution. It doesn't matter how large your sample size is, you have to know that your population is normally distributed. And this is everything on how to decide what test to use. It is exactly the same as how we decided what test to do on our confidence intervals. And we're done with statistics.